Hey everyone, welcome to a new episode of Engineer with Wisdom. Today's topic is actually gonna be a little bit different. We're not gonna go solving problems. I actually want to discuss a topic for you guys. And this um, topic obviously is load transfer, right? So we're gonna be discussing load transfer, and I'll be running you guys through what this means and why it applies to civil and structural engineering. Okay. So load transfer essentially is its definition. If I were to put it in simple terms, it would be how to get the loading that is applied on a on a structure to, and this should also be kind of obvious, but I'll go ahead and explain um, what this term is. So how to get the loading that's applied on a structure, oops, a little bit of a bad line, to the foundation. So that's kind of what we're talking about with load transfer. So if you were to imagine um, different types of loads on this building, you could think of a dead load, which means the primary structural member of the building. So primary, and I'll give an example of a dead load. Um, you can think of a dead load as a column or a beam, or if you want to be a little bit more specific, a girder. Girders are just essentially bigger versions of beams. If you were to imagine a I-beam like so, this is what that is, and a column is pretty much this number right here. So this is a column. It's a great example of a column. Okay, so I'll go ahead and erase those. Excellent. So that's loading number one. Another different type of loading you could think of is a live load. Live load usually consists of unprimary, or I would say not primary members of a structure, but they are very important. So an example of a live load are furniture, or another example of a live load could be people. So if you imagine, take a closer look here on this level, if you were to look at this floor, so you could imagine there's a person here, hello, another person here, hello, and if you were to look on the third floor, maybe there's a very big guy like that, and a huge person whose head you cannot even see as his jaw half of his head because the other half of hidden over here. So these are examples of live load. And you need to account for these types of loading because in the analysis of a building, you want to consider any possible loading that may occur onto the structure so that you can design for the building's loading type. So in ASCE, there's a bunch of codes, correct? And ASCE stands for Associated Society of Civil Engineers, and this is where they lay out the codes. Codes meaning what is allowed, what is not allowed, minimum standards, basically the law. And in these laws, they will talk about live loads, they will talk about dead loads, even wind load, earthquake, and so on and so on and so on. And they are basically saying, here are all these possible types of loading. You need to design your building to be safe in any one of these types of loading. So that's essentially the code in which you're designing for. And so that goes to example loading type 3. And loading type 3, I would just say wind load. And it's primary. It is actually not primary, as I wrote here. So not primary again. Excuse me. And this is essentially a factor in which you have to consider for designing your structure. Because you don't want your building to suddenly, I'll do this in blue. You don't want a bunch of wind coming this way. Just imagine some very strong wind, let's say 60 miles per hour wind going all in that direction. Okay? You do not want your building to suddenly, I'll do this in red, a little bit thicker, to suddenly start tilting like so. And then you will have that would be extremely dangerous for your building. Here are your windows. That is what you don't want. And so that is why when you are designing, you take into account all of these wind loads, and you make your structure strong enough so that this will never happen. Or at least design it so that it does not hurt the building at all. Okay? So those are the different types of loading that I just wanted to mention. And this goes back to the topic of load transfer. So I drew over here a really quick sketch of things that you should know. Okay, so go ahead and draw a couple scenarios. Okay, so let's say this is element 1, this long one right here is element 2, this one vertical right here is element 3. Oops, little typo. This is element 3, 4, 5, and then 6. Okay. And these should be connected like so. This should be connected like so, and so on and so on. So let's say, for example, that a lot of snow decided to fall on your roof. It is winter, okay, of 2020, and you are in the mountains. So imagine you're in the mountains, and all of a sudden, you get a world record amount of snow. World record snow. So for some people, you would think, wow, we're gonna play in the snow. We have a lot of snow. Whoa, 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 whoa. Okay, that's what some people would think. Kids would play with their snow, have their little beanie on, make sure they're warm. But as engineers, here's what we're thinking about. All of the snow is gonna pile up on top of this building, correct? So now you have to consider, how is this building gonna hold all of the snow in the winter of 2020? So here's how engineers think. We design our beams and columns to take up a lot of load. So what does that mean? So we design these beams, columns, to be strong enough to transfer load. So for beam 2 that I am drawing right now, this is going to take up so much load from the snow. Because as you can imagine, this is going to be in 3D. You have a surface of a roof, like so. So all of this snow is on this surface. And like so, you would have all of that snow on this surface. And I'll just draw it. You have a bunch of snow on this surface. So now, your roof is filled with snow. How do you want to move the weight of the snow from the roof down to the foundation? This is the foundation. The foundation is all of the stuff below the building. Foundation. It's connected to the earth. So here is below the ground. This is underground. Okay. So now let's say you're at the roof, you have all of the snow, you want to transfer it. So first off, it's gonna move from this roof over here that I'm highlighting now. Might as well use a highlighter. From here into this beam right here. Then this beam will act in tension and compression, whichever way it feels. Then move all of the loading into this column right here. They'll go from the roof here to this beam, outwards in these two directions, down, 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 down. It may transfer even here at this joint, and will go out and out, and same thing will occur with this roof, where it's taking up a whole lot of loading. So all of this snow over here will want to get down to the foundation. So now this is where beams, columns come together. and work together. And so now these columns are perfectly designed to hold so much weight from anything that is above the column. Okay? So that is like so. These columns are extremely thick. They have a radius that is incredibly large. You could imagine here that it is um, a 2 feet radius. 2 feet is equal to R. And so this is going to hold a massive amount of weight because it is extremely strong. And now all of that weight from the snow is going to transfer from here into these beams over here, okay, and down into the column. And this column will take you straight down to the foundation. Straight down to the foundation. Like so. And once it reaches the foundation, it's basically saying, hey, I finally reached the ground. The earth can carry the rest of it because the earth is just so big compared to everything. This is earth. All of that little weight that you see from the snow does not compare to the amount that the earth can carry. This is all of earth. I'll draw a little bit thicker. So the earth can carry a whole lot. You just want your snow to transfer through the building so that the building, I think I should write this down, the building remain safe. And more importantly, I think more importantly, these people right over here remain safe. So that is the topic I wanted to discuss to you guys about load transfer. Hope you guys enjoyed the video. If you liked it, give it a thumbs up. Didn't like it, keep your thumbs down. And until next time, engineer with